والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is the last section in chapter 7, section 7.3, and chapter 7 is about sampling distributions. We studied in 7.2 sampling distribution of X bar, and now in 7.3 we study sampling distribution of sample proportion or P bar. So sample proportion, sampling distribution of sample proportion. In many instances, the objective of sampling is to estimate a population proportion. So this is what we are going to do in chapter 8. We will estimate the population proportion. For instance, an accountant may be interested in determining the proportion of accounts payable balances that are correct. A production supervisor may wish to determine the percentage or proportion, similar, of product that's defect-free. A marketing research department might want to know the proportion of potential customers who will purchase a particular product. In all these instances, the decision makers could select a sample, compute the sample proportion, and make their decision based on the sample results. And that's what we are going to do exactly in chapter 8. So let us differentiate between population proportion and sample proportion. To find population proportion, we divide X by capital N, where capital X is the number of items in the population having the attribute of interest, and capital N is the population size. So the population proportion is denoted by P, while the sample proportion, we will call it P bar, and it is also X over N, small letters, where X is the number of items in the sample with the attribute of interest, and small n is the sample size. So this relation is important. This is how to find the sample proportion. Now, the difference between the sample value and the population value is sampling error. As we have seen in section 7.1, the sampling error of the mean is X bar minus mu. So the sampling error for a single proportion, yani one proportion, yani we have one population, because you are going to study in the next course two proportions, the difference between two proportions, you will deal with two populations. Here we deal with one population only. So what would be the sampling error? P bar minus P, the sample proportion minus the population proportion will give you the sampling error. Now, what is the sampling distribution of P bar? You will be interested in determining the proportion of all items in a population that possesses a particular attribute. The best estimate of P will be P bar. Okay, the best estimate of P, the population proportion, is P bar, the sample proportion. However, any inference about how close your estimate is to the true population will be based on the distribution of the sample proportion. So we need to know the distribution of P bar. Okay, mainly it is binomial, but under these conditions, if the sample size is sufficiently large, and sufficiently large here means that n times P is greater than or equal to 5, and n times Q is greater than or equal to 5. If you remember, in the binomial distribution, P is the probability of success, and the Q1 minus P is the probability of failure. So if these two conditions satisfied, then we can use the normal distribution to approximate the binomial distribution. So we will have this theorem that regardless of the value of P, which is the population proportion. Of course, P is not 0 and is not 1. It's a number between 0 and 1 in this case. The sampling distribution for P bar will be approximately normal, is approximately normal, with mu P bar equals to P. So what is the mean? What is the mean of P bar? It is P. What is P? The population proportion. Like with the mean, mu X bar is mu, and mu P bar would be P, the population proportion. And the standard error or the standard deviation of P bar is square root of P times Q over N. So where P is the population proportion and Q is 1 minus P. So the distribution of P bar is normal with mu equals to P, sigma equals to P times 1 minus P over N under these two conditions. Now we can change P bar because the sampling distribution of P bar is normal, so we can change it to the standard normal, which is Z. How? We subtract P bar minus mu P bar, which is P, over sigma P bar, which is square root of P times 1 minus P over N. So this would be the formula to change from P bar to Z. And now we can answer questions like this. A population has a proportion equal to 0.3. Population. So this is the proportion of the population. So it is P. So P is 0.3. Calculate the following probabilities with N equals 100. How to calculate this probability? We change it to Z. Why? Because the distribution of P bar is normal. Of course, the condition must hold. So if you check N times P, 100 times 0.3, it would be 30. So it's greater than 5. And N times Q, where Q is 0.7, would be 70, which is also greater than 5. So always in the questions, if he asks about probability of P bar, these two conditions would be satisfied. So we change it to Z. We say probability of Z less than or equal to 0.35, and we change this value to Z. So we need to find the mu P bar, and the mu P bar is P, and P is 0.3, and sigma P bar is square root of P times 1 minus P over N. So it is P is 0.3, 1 minus P is 0.7 over N, and N is 100. All right. So you can approximate this square root, or you can put it as it is if you want the exact answer. 0.3 times 0.7 over 100 inside the square root. This would be 0.0458. Okay, take at least 4 or 5 decimals. 0.35 minus P is 0.3 over sigma P bar, which is 0.0458. I can say also 3. So use the calculator to simplify this. So I'll say 0.35 minus 0.3 divided by the answer, which is this one. And now you need to approximate to 2 decimals, and you will have probability of Z less than or equal to 1.09. And to find this probability, you go to the standard normal and find this probability. If you remember, if you want to graph to help you finding this probability, the mean of Z is 0. So 1.09 is a number to the right of 0, and he needs the probability that Z is less than 1.09, so he needs the area to the left of 1.09. Well, this I can find from the table, and this is 0.5. So the probability of Z less than or equal to 1.09 is 0.5 plus, and I can go to the table, the normal distribution, the Z table, and I look to the number 1.09. Okay, this is 1.09. You go here to the last number, 0.3621. 0.3621. You add this to 0.5 and you get the result. So the answer is 0.5 plus 0.3621, and it would be 0.8621. This is the probability that P bar is less than or equal to 0.35. You can change this to Z and find this probability also. And also you can find the probability between these two numbers. Please do it. And this one too. This would be an exercise for you. Another question. If a random sample of 200 items, so this is small n, is taken from a population in which the proportion of the population of items is 0.3, so P is 0.3. What is the probability that the proportion of successes in the sample, proportion in the sample, so he's asking about P bar. So what is the probability that P bar is less than or equal to 0.27? So you just find it would be, and it is a sampling distribution of P bar is a normal distribution with the mu equals to P, which is 0.3, and sigma is equal to 0.3 times 0.7 over n. N in this case is 200. So you change it to Z, it would be probability that Z is less than or equal to 0.27 minus 0.3 over this one, sigma 0.3 times 0.7 over 200. It is approximately 0.0324. Okay, so if I divide 0.27 minus 0.3 by the standard error, I will get probability of Z less than or equal to negative 0.925, so I'll make it 3. How to find this probability? Again, you draw a graph. This is Z, this is 0, negative value, so it's to the left of 0. Less than, so it's to the left of negative 0.93, so I need this area. Now to find this area, this one would be given in the table, and all of this is 0.5, so you write it 0.5 minus the area when you look to 0.93 in the table. So if you look to 0.93, this is the answer. So it is 0.3238. 3238. Okay, this is 0.93. So the answer would be 0.5 minus 0.3238, and then when you subtract, you get 0.1762. Another question, the proportion of items in a population that possess a specific attribute is known to be 0.7. So 0.7 is P, the proportion population. The sample size is 100. And the proportion of items in the sample that contains the attribute of interest is 0.65. So 0.65 is B bar. Okay, what is the sampling error? Well, the sampling error is P bar minus P. So it's 0.65 minus 0.7. So it is 0.05, negative 0.05. That's the sampling error. Referring to part A, what is the probability that a sample of size 100, so this is a small n, would have a sample proportion, this is P bar, of 0.65 or less? So what is the probability that P bar is less than or equal to 0.65 if the population proportion, which is P, is 0.7? So again, the distribution of P bar is normal, so you need to change this to Z. So it is 0.65, you subtract from P, which is 0.7, and you divide by square root of P is 0.7. You multiply by Q, which is 1 minus 0.7, which is 0.3, and you divide by the sample size, which is 100. You change this to Z, and then you find the probability. Another question, given a population in which the proportion of items P is the population proportion. If a sample of 400, so this is N, what is the standard deviation of the sampling distribution of P bar? So he's asking about sigma P bar. What is sigma P bar? It is square root of P times 1 minus P over N. So it's square root of P is the population proportion times 1 minus 0.25, which is 0.75, over N, which is 400. This is the standard error, okay, or the standard deviation of P bar. So if you calculate, the answer is 0.02165. What is the probability? The proportion of successes in the sample. So P bar, he is asking about probability that P bar will be greater than 0.22. You change it to Z greater than 0.22. Subtract from P. What is P? P is 0.25. Divide by sigma P bar, which is 0.02165. You use the calculator to evaluate this. And now you have a value in Z, which is -1 greater than -1.39 if you round to 2 decimal places. Now to find this probability, this is Z, the standard normal distribution. The mean is 0. -1.39 is a number here. Greater than would be all of this area. So this is 0.5, and you can find this from the table when you look to 1.39. So it's 0.5 plus the area in the table, and you find the answer. Another question, given a population in which the probability of success is 0.2, if a sample of 500, this is N, calculate the probability, the proportion of successes in the sample, so this is P bar, will be between, now he is asking between, so 0.18 is less than P bar is less than 0.23. You change it to Z. Change these two numbers to Z values. So subtract 0.2, which is P, over sigma P bar, which is square root of 0.2 times 0.8 over N, which is 500. This is less than Z, less than 0.23 minus 0.2 over 0.2 times 0.8 over 500. Now, when you evaluate all of this, you will get the following. 0.18 minus 0.2 over square root of 0.2 times 0.8 over 500. The answer is negative 1.118, so it would be 12 less than z less than. So here now I have 0.23 instead of 0.18. So the answer would be 1.677 or 1.68. And to find the probability between these two values, you add the probability between 0 and 1.68 to the probability between 0 and 1.12, because one of them is negative and the other one is positive. So you find this area from the table and this area from the table, and you add these two areas. Calculate the probability of the proportion of success between 0.18 and 0.23 if the sample size is 200. This is just similar. Please do it. Another question, given a population in which the proportion of items p.5 sample in 200, find the probability that the proportion of success in the sample, so p bar, is between 0.47 and 0.51. This is just similar to the previous question. Referring to part A, what would the probability be if the sample size were 100? So it's exactly the same question, but once A when n is 200, B when n is 100, you will find the difference between them. The last question, given a population in which the probability of success is 0.4, this is small n, calculate the probability, the proportion of successes in the sample, so probability that B bar is less than 0.42. You change it to Z and find the probability. And here, what is the probability? The proportion of success in the sample will be greater than 0.44. So what is the probability that B bar is greater than 0.44? Let us solve this one. It is the last part. We change it to Z. So we write it Z greater than 0.44 minus P. What is P in the question? It is 0.4. So minus 0.4 over sigma P bar, which is 0.4 P times 0.61 minus P over N. N is 1,000, sample of 1,000. So N is 1,000. We calculate this and we write the answer. So 0.44 minus 0.4 over the square root of 0.4 times 0.6 over 1,000. The answer is 2.58. 1, so it's 2.58. Notice that 2.58 is a positive number and we need the area to its right, so it would be 0.5 minus this area, and this area you can find it from the table. It is looking at 2.58, so this is 2.5 and this is 8, so 0.4951, 0.4951. So the answer would be 0.5 minus 0.4951, and the probability is 4.9 times 10 to the power negative 3, or if you use shift ing twice, you get 0.0049. This is the end of section 7.3 and chapter 7. Next time we will start chapter 8 بإذن الله.